talked about what I, bless you. Yesterday we talked about what I equaled. Raise please, what did I equal? Don't yell it out, raise please. Go ahead, Rachel. Square root of negative 1. So before we press on today and do our operations, I want to know what I squared equals. And keep in mind, all you have to do is take our little equation here, and if you square one side, you have to square the other. So anybody out there know what I squared equals, please? Max?
Negative 1.
It is. When you square a square root, all that happens is the root goes away and you have negative 1. So I squared equals negative 1. And on a complex coordinate plane, the x-axis is called the real axis, so that's where the real part goes. The y-axis is called the imaginary. So that's where the imaginary part of the complex number goes. Okay? So let's say we plot a point right here. And let's say on the real axis, it's over A units. Okay? And on the imaginary axis, it's up BI units. So it's over A, up BI, okay? So this point right here is A plus BI. Now, they're going to ask you to plot a point, and they're going to ask you to find the magnitude. Okay. Now, really, there's two ways that we can attack this. Magnitude is also called absolute value of a complex number. So whenever they say magnitude, that is also considered to be absolute value, and vice versa. So if on the homework they ask you for the absolute value, that's the magnitude. And the magnitude is defined as the distance from 0, 0. So they want you to find that distance. Okay? Now, what's a way that we know how to find that? The magnitude is defined as the square root of the real part squared plus the imaginary part without the I in it. So just like Pythagorean theorem. A squared plus B squared equals C squared. So that would be this length right here. And it's defined as the square root of A squared plus B squared. So I don't care, guys, when you do absolute value magnitude if you use this formula or if you use Pythagorean theorem. I'm fine, because both will work. All right? All right, example 1 is graph and find magnitude. I've got 4 of them. I think I'll split you guys up into 4 different groupies. Okay? So letter A is 3 minus 2i. Let's have Matt Sarver's group and Remy's group do that one. Letter B is negative 2 plus 4i. Okay? Let's have Kayla's group, Max's group do that one. Letter C is just 3i. Okay? We're going to have Sierra's group do that one. And then letter D is negative 4 minus 3i. And we're going to have table group. You guys do letter D. Okay? So you have to graph on a coordinate plane. And then you have to find the length or magnitude of that complex number on the coordinate plane. How many ticks on the real axis do I have to go over?
3.
Left or right?
Right.
Good. And Haley, on the imaginary axis, where do you want me to go? Down 2. So there is the point 3 minus 2i. Okay? All right. We'll talk about magnitude in a second. Let's go to Joel.
Yes.
Letter B. How do you want me to graph this?
Go 2 ticks left.
Good?
And then 4 ticks up.
Good. And there's the complex number, negative 2 plus 4i. Very good. Now, Miss Natalie,
Yes.
how do I graph 3i?
You go 0 tick marks on the x-axis or on the real axis.
Yep.
And then go 3 tick marks up.
Excellent.
How do you make that a triangle?
What we could do is we could have rewritten this as 0 plus 3i, which is fine. All right, Nat, how do I graph letter D?
You go down 4 in the imaginary one.
Mm-hmm.
And then left 4.
Good.
So you have negative 4, negative 3. And then
So negative 4, negative 3, right about there. Excellent. Okay. All right. Back to letter A, the magnitude. Can you set us up, Autumn? So square root of?
square root of 3 squared plus negative 2 squared.
Delightful. Math Sarver, 3 squared is? And negative 2 squared is? And final answer, Hannah, square root of? Very good. That's called the magnitude or the absolute value. Okay. Form. Oh, look at, I wrote 4.
Yeah, that's what I was wondering.
Yeah, I was wondering that too. I have no idea why I wrote a 4 and not a form. Okay. All right. Square root, negative 3 times square root, negative 12. Can we multiply things that are under roots? Yes, we can, but as soon as you have a negative under the root, you must, before you multiply, pull out an I. You must pull out an I. You have to pull out an I, okay? So the first one, square root of negative 3, we're going to write as I root 3. And square root of negative 12, we're going to write as I root 12. So guys, you cannot multiply till you pull out the I. All right, Natalie, what is I times I?
9 times 5 is negative 1.
Well, okay, do the, I know, skip, what is I times I normally? I to the,
Second.
thank you. And then I'll let you do the 1 next. So I squared, and Natalie, then what's 3 times 12?
12 is 36.
36. And what Natalie just said, very important from up at the top here, we said I squared is always negative 1. So don't ever leave an I squared. We're going to replace that with negative 1. Okay? And Sierra, what's the square root of 36? 6. So now we have negative 6. Final simplified answer. All right, guys? Letter B. Square root negative 48 minus square root negative 27. Now these have in the past presented issues for people. Okay? Leah, what would you do first?
First you would take the negative root out and make that into...
And I'm sorry, this negative shouldn't be on the outside, it's on the inside.
Okay.
So pull out an I.
Yeah.
Okay. Now, can we do 2 things in one step, guys? Can we pull out the I and break down 48? And can we do the same thing with this? Pull out an I and break down 27. Now, I'm hoping it's not messing you up because I don't have any of the perfect squares up on the board. Yes, Autumn?
It's gonna be 4 root 3, so then it's gonna be root
Okay, so what times what is 48?
3. 16 times 3.
Excellent. And what times what is 27? 9 times 3. Okay, and now Autumn, you keep going.
So it's gonna be square root of our 2 root 3. Or
Square root of 16 is what?
4.
4 root 3 minus
Minus 3 root 3.
minus 3 root 3. Okay? Now, in order to add or subtract things with roots, what you have to have is you have to have things called like radicals. So what's under the radical has to look exactly the same. Do they look exactly the same?
Yeah.
Yes, they do. Okay? Now, you don't have to rewrite this like I am, but I'm going to rewrite this for you. So it's 4 root 3. The I goes at the end, always at the end. Minus 3 root 3. I goes at the end. We said these are like radicals.
Root 3i.
Okay? First of all, Leah, what's 4 minus 3?
1.
1. Okay? The like radical is what, Leah?
3i.
Where'd the root go?
3. Square root of 3.
Square root of 3. I. Now, does a 1 times anything really do anything?
No.
No. But I want to write this in true complex form. That means there's a real part, and that means there's an imaginary part. We already have the imaginary part. Raise, please. Does anybody know what the real part is? Go ahead, Rachel.
0 plus 3i.
So it's 0 plus, you're fine, there's no negative here, so don't put a minus in. Root 3, and at the end, put your I.
Why?
Geometry test. Okay, we weren't working with imaginary numbers, but we were working with taking a binomial. Binomial means 2 terms, and squaring it. And there's only one way to square a binomial. Foil, very good. And those guys did not foil, so that's where they made their mistake. Before we foil, can we write it now twice times itself? And in the process, can we pull out the I right away? So negative 1 plus root 3 I times negative 1 plus root 3 I came out. All right? Now, let's see if you guys remember how to foil. First, last. This is the inside. These are the outsides. Okay? Anybody a confident foiler? I'll point at the things you have to multiply. You just go ahead and multiply. Leah, you're gonna go?
Yeah, negative 3i.
Okay, first. First times first.
Negative 3i. Oh. 1.
1. Okay. Leah, outside. You said negative root 3i?
Yeah.
Yes. Leah, inside.
Negative root 3i.
Leah, last times last. What's root 3 times root 3? Square root of?
3.
3 times 3 is?
9.
9. So plus square root of 9. And Leah, what's I times I?
I squared.
I squared. Okay? So the 1 is going to come down. Are these like radicals max?
Yes.
Yes. So what's a negative 1 root 3? So we could throw 1 in front of here. And a negative 1 root 3 max. Negative 2. And the like term never changes. So the like radicals are root 3. Those have to stay root 3. And the like term i's and i's are i's. Okay, we're not multiplying i's so we don't get I squared. Okay, everybody good? Brianna, what's the square root of 9? 3. And Brianna, what is I squared?